The word polymorphism means many forms, and in programming, it refers to methods, functions, or operators with the same name that can be executed on many objects or classes. An example of a Python function that can be used on different objects is the len function. For strings, len returns the number of characters. For example, here we have a string hello world. So if we print the length of this string, we get the number of characters 12. 1, 2, 3, 4, 5. Space also counts as a character. So 6, 7, 8, 9, 10. And special characters also count as characters. So here we have 12 characters. For tuples, len returns the number of items in the tuple. For example, here we have this tuple, apple, banana, and cherry. And so if we print the length of this tuple, we get 3, which is representative of the number of items that we have in this tuple, 3 items. For dictionaries, len returns the number of key and value pairs in the dictionary. For example, here we have this dictionary, and if we print the length of this dictionary, we get 3, which is the number of key and value pairs that we have in this dictionary. Polymorphism is often used in class methods, where we can have multiple classes with the same method name. For example, here we have 3 classes, car, boat, and plane, and they all have a method called move. So here we create an object of each of these classes, car, boat, and plane, and we execute the same method move on all 3 class objects, car 1, boat 1, and plane 1. So even though it's the same name, notice when we run the program, we'll get a different output. Drive for car, sail for boat, and fly for plane. So essentially, the move method polymorphed or kind of changed shape based on the object it was being called for. Otherwise, if it did not polymorph, it wouldn't really make sense if we said something like the boat drives or the plane drives. Or it wouldn't have made sense if we said the boat flies, right? So, in other words, we need this polymorphism to happen in order to actually have realistic behavior as an output. In this case, the car drives, the boat sails, and the plane flies, polymorphing based on each object. What about classes with child classes with the same name? Can we use polymorphism there? Well, yes, if we use this example and we make a parent class instead called vehicle, like this one, and we make car, boat, and plane objects as child classes of the vehicle class, because all of these objects, car, boat, and plane, technically are vehicles that have shared properties like brands and models, and methods like move, because they all move as well in their own ways, then the child classes can inherit the vehicle method, in this case move, and override them to represent their own behavior. So here we have the car class empty, so we're using the pass statement to leave it empty, which means we're essentially just inheriting move as is from the vehicle class. In the vehicle class, it just says move, and technically speaking, the car moves. So there's no need to redefine it here in the car class because it already does the behavior we expect the car to do. Boat, however, it makes more than just moving, right? It sails. So we can override it with its own distinct behavior by redefining the output. And instead of saying move, we say sail. And we do the same thing for the plane. We redefine the output to say fly instead of move, so it's specific to the plane. Essentially here, we're keeping the same name inherited from the vehicle class, move, and just changing or polymorphing the output to represent each respective object. So now when we run the program, we'll get the properties of each of the objects. So car, we have Ford Mustang, and the car moves, which is inherited from the vehicle class, move. And then for the boat, we have a brand and model Ibiza Touring 20, and the boat sails. So here we are overriding the behavior inherited from the vehicle class on the move method by its own distinct output, sailing. And for the plane, we have a Boeing 747, and the method move is overridden with an output of fly for the plane object. So the plane flies instead of move as it's defined in the vehicle class. So here we are overriding the output behavior for the plane from move to fly. In other words, we're changing that behavior, changing the output, polymorphing. So because of polymorphism, we can execute the same method for all classes.